Modern warfare is no longer about a single weapon finding a single target. It's about networks deciding outcomes before humans can even process what's happening. That's where predictive battlefield AI, often called kill webs, comes in. Traditional combat systems operate in chains. A sensor detects a target. Information is passed to a command unit. A weapon is selected. An operator approves the action. Each step adds delay. Kill webs erase that delay. Instead of linear chains, kill webs use AI to link every sensor, platform, and weapon into one constantly updating network. Satellites, radar systems, ground vehicles, aircraft, drones, and electronic warfare units all feed data into the same decision layer. The AI doesn't just see the battlefield, it models it. Using predictive algorithms, the system estimates enemy intent, movement probability, response timing, and vulnerability windows. It doesn't ask where is the threat now. It asks what sequence of actions is most likely next. Once that prediction is made, the AI assigns roles automatically. One platform tracks, another jams communications, a third prepares the engagement. The weapon that fires may never have directly detected the target at all. That's why it's called a kill web, not a kill chain. The web dynamically reroutes decisions in real time. If one node fails, another replaces it instantly. If a weapon becomes unavailable, the system reallocates the task without human intervention. Speed is the advantage. In high-intensity environments, human decision cycles are simply too slow. Kill webs compress observation, orientation, decision, and action into near-simultaneous execution. Engagements can be resolved before an enemy even realizes they've been detected. This isn't about autonomous weapons firing indiscriminately. Most operational systems still keep humans on the loop or in the loop for authorization. But the planning, prioritization, and sequencing happen at machine speed. That distinction matters. Because once one force uses predictive kill webs, opposing forces are forced to respond in kind. The battlefield becomes less about individual skill and more about whose network thinks faster, adapts quicker, and survives disruption longer. There are risks. Kill webs depend on data integrity. If inputs are corrupted, spoofed, or manipulated, decisions can cascade incorrectly. That's why cyber defense, redundancy, and verification layers are just as important as firepower. There are ethical questions, too. When AI recommends lethal action faster than humans can evaluate it, accountability becomes complicated. Militaries worldwide are still drawing lines around autonomy and control, but the direction is clear. Predictive battlefield AI represents a shift from reaction-based combat to anticipation-based dominance. Victory no longer depends on who shoots first, but on who understands the future of the fight first. And in that future, speed isn't just an advantage, it's the battlefield itself.